Okay, Assalamualaikum. My name is Muhammad Haris Imtiaz, that's me. So, I will explain my slide first. Chapter 3 about electrochemistry. So, this is redox reaction. What is redox? Redox is short for oxidation reduction reaction. That's both process occur simultaneously, which means one species is oxidized and another is reduced. So everyday redox reaction include, for example, combustion, respiration, and the last one is photosynthesis. And also there have three definition of oxidation and reduction. Okay, so this is for the first one is gain or loss of O. So what is O? O is oxygen. So this is in term of oxygen. We have oxidation and reduction. So for oxidation is gain of oxygen in a species. For example, Mg is oxidized to MgO. And also for reduction is loss of oxygen in a species. For example, H2O is reduced to H2. Okay, and the second one is gain or loss of H. H is hydrogen. Before this slide, we have gain or loss oxygen, but this slide we have hydrogen. So this is in term of hydrogen. Oxidation is loss of hydrogen in a species. For example, H2O is oxidized to O2, and reduction is gain of hydrogen in a species. For example, O2 is reduced to H2O2. Okay, so this is oxidation and reduction. But redox reaction can also be defined as reaction involving transfer of electron from one atom to the other. And we have oxidation and reduction. Oxidation is loss of electron in a species, and that is become more positive. And also reduction is gain of electron in a species, but is become more negative. And as we can remember it, for oxidation is become more positive, but for reduction is become more negative. Alright, this is oxidizing and reducing agent. We have two types for oxidizing and reducing agent. So we go to the first one is reducing agent. Reducing agent is when a species donates or loses electron, that we call it oxidize. While for oxidizing agent is when a species accepts electron, that we call it reduce. Okay, so this is example for and we have half equation. For example, okay, at the left side we have Fe plus Cu2 plus, and at the right side we have Fe2 plus Cu. Okay, so in this case, in this redox reaction, Fe is lost electrons and become Fe2 plus. Since it lost electrons, it's oxidized and acts as the reducing agent, while Cu2 plus is gain those electrons to become Cu. So Cu2 plus is reduced and acts as the oxidizing agent. Okay, so this is a good way to remember. Oxidizing agent gets reduced and reducing agent get oxidized. Okay, so that's all part from me for the explanation. Thank you.
Hello everyone, my name is Iman Hakim Rashidan. My ID is 2024415154. And in this part, I'll explain what redox reaction are, oxidation numbers, and how to balance redox equation in acidic and basic solution. So, what is a redox reaction? Redox means oxidation and reduction. Oxidation is losing electrons and reduction is gaining electrons. For example, Al is oxidized to Al plus 3 and Fe plus 3 is reduced to Fe. Moving on to determine oxidation numbers. To check electron transfer, we use oxidation numbers. For example, Br2 and O3 are both 0, while Na is plus 1 in Na. Okay, let's balance this in an acidic medium. First, we got the reaction of zinc plus VO2 plus turn to zinc 2 plus VO2 plus. For oxidation, we will lose 2 electrons plus, so it becomes zinc 2 plus. So then you're gonna put plus 2 electrons. For reduction, you will lose electron, you will gain electron, so become VO2 plus. Then you're gonna plus with 2H, means that it's plus 2 electrons, and return to VO2 plus H2O. Now for the final balance equation is zinc plus 2VO2 plus 4H and will turn into zinc 2 plus 2VO2 plus and plus 2H2O. VO is vanadium, by the way. And in basic medium, the steps are similar, but instead of H plus, you add OH minus to balance it. But today, my focus is only on acidic medium. It's generally the same. And to summarize my slide part, redox is an electron transfer. Oxidation means losing electrons. And in acidic medium, we add H and H2O to balance out the chemical reaction.
Types of reduction. Type of reduction have 4, which is metal displacement, halogen displacement, electrolytic cell, and chemical cell. Next, displacement reaction. In a displacement reaction, an ion or atom in a compound is replaced by an ion or atom of another element. For example, metal displacement and halogen displacement. First, we look for metal displacement. Metal displacement is a metal ion in a compound is replaced by another metal. For example, formation of copper metal when zinc metal is placed in a copper sulfate solution. Okay, next we look for electrochemical series. The electrochemical series is easy to understand because the higher in a series, the more reactive it will be. Alright, next we go to halogen displacement. One halogen can replace another less reactive halogen from a solution to form a new one. Example, displacement of bromine ion from potassium bromide solution by chlorine gas. So what happened in the example? Okay. The happen is chlorine is more reactive than bromine. So chlorine displaces bromide ion from potassium bromide solution. As a result, chlorine become chloride ions, bromide ion become bromine molecules. So next we go to electrolytic cell. An electrolytic cell use electricity to do a chemical reaction. The chemical reaction that takes place in a redox reaction, gaining and losing electrons. Alright, so what happened at each electrode? Okay, first we must know the anode always be positive and cathode always be negative. Oxidation always at anode and reduction always at cathode. Okay, so when the process is happen, the oxidation is loss of electron, and at cathode the reduction is gain electron. Next is galvanic cell. Galvanic cell, also known as Daniell cell or voltaic cell, change chemical energy to electrical energy through redox reaction. In galvanic cell, it don't need battery because the chemical reaction itself generate electrical energy. So what happened at each electrode? For anode, it just negative, and the oxidation, it lost electrons. For cathode, it charged positive, and the process is reduction and it gains electron. Galvanic cell, it have sub-bridge, and electrolytic cell don't have. So it's easy to know which is galvanic cell or electrolytic cell. Just look.
Hello and Assalamualaikum. My name is Adam Aris bin Shamsul, and in this section of Chapter 3 Electrochemical, I will talk about conductor, non-conductor, electrolytes, and non-electrolyte. So, what is electrical conductivity? Electrical conductivity is the measure of the amount of electrical current a material can carry. There are two types of conductors and non-conductors. Conductors is a material that allow the flow of electrical charge, while the non-conductor is a material that does not transmit electrical charge. And then there is electrolytes and non-electrolytes. Electrolyte is a substance that conducts electricity when it's melted, such as seawater, while the non-electrolyte is a substance that does not conduct electricity when it's melted. And this is electrochemical cell. So what is electrochemical cells? Electrochemical cells is a device that can generate electrical energy from chemical reaction. It's generated due to movement of electron. It involves a redox reaction happening at the anode and cathode. There are two types of electrochemical cell. There is galvanic cell that convert chemical energy into electrical energy, and there is electrolytic cell that is used to force chemical reaction to happen. And lastly, what is the reaction happen at anode and cathode? While at anode, negative electrode, there is a negative electron reside, and the oxidation occurs at anode. Electron move out from anode, and cathode is a positive electrode, which is the reduction occurs, and the electron will move into the cathode. And that's all from me. Thank you and goodbye.